Hello friends, continuing with the chapter of current electricity. Today we come to the fifth part of the topic measurement of EMF. That is, today we are to carry out measurement of EMF of a cell. So today's topic is measurement of EMF of a cell. After learning about EMF equation of a cell, series, parallel and mixed combination of cells, we actually come to the topic measurement of EMF of a cell. So today's topic is measurement of EMF of a cell, the title that we have reflected in the mind map. Now EMF of a cell is measured with the help of potentiometer, whereas PD is measured with the help of voltmeter. Now what is potentiometer? And potentiometer is an apparatus used for measurement of number 1, potential drop along wire, number 2, EMF of a cell, number 3, for comparing EMFs of primary cells, and number 4, for determining internal resistance of a primary cell. Now here you look at the circuit diagram. AB is potentiometer wire, MA is milliampere meter, E is EMF of the cell, RH is rheostat, and V is voltmeter. Okay. Now this is how setup of potentiometer comes out to be. Let us look in more details in the coming slides. Now principle of potentiometer. When a steady current is maintained in a wire of uniform area of cross section, then potential drop along wire is directly proportional to the length of the wire. I repeat, when a steady current is maintained in a wire of uniform area of cross section, then potential drop along wire is directly proportional to the length of the wire. That is, V is directly proportional to L, where V is potential drop across length L of the potentiometer wire. Or we can write V is equal to KL, where K is constant of proportionality known as potential gradient. Now what is the value of K? What is the expression of K, you can say? Let us try to understand. Now according to Ohm's law, we know V is equal to IR and R is equal to rho L by A. Therefore, we write V is equal to I into rho L by A, or we can write KL, where K is equal to I rho by A and is constant quantity for a given wire, which we call it as potential gradient. Now here look at the diagram. AB is potentiometer wire, MA is milliampere meter, E is EMF of the cell, and RH is rheostat, which regulates the current through the wire. So I is the steady current passed through this wire of uniform area of cross section. And here is the voltmeter, which is connected to point A on one side and the other side with a sliding contact. Now when we move the sliding contact from A to B, we find that V goes on increasing, that is potential drop across the length L goes on increasing with the length. So V and L are in direct proportion. Therefore, we have V is directly proportional to, or V is equal to KL, where K is potential gradient and the constant of proportionality. So mathematically we can say V is equal to KL for a potentiometer. Now potential gradient, let us define potential gradient now. Since Potential drop V is directly proportional to length of the potentiometer wire, and therefore V is equal to K into L, or K is equal to V by L. So from here we try to define potential gradient. First definition: potential drop along the wire per unit length when a steady current is maintained through a wire of uniform area of cross section. I repeat, potential drop along the wire per unit length when a steady current is maintained through a wire of uniform area of cross section is defined as potential gradient. Second, SI unit, volt per meter, because K is equal to V by L. So for V we have volt, for length we have meter. Therefore SI unit is volt per meter. Now 3, VL graph. If you draw VL graph, this is V, this is length L. If we draw VL graph, then it comes out to be a straight line as shown. Fourth, alternative definition of potential gradient. Slope of VL graph is also defined as potential gradient. So this is VL graph, which is a straight line, and its slope is theta, that is tangent theta is the slope, that is perpendicular over base, which is V by L. So V by L is the tangent theta and is the slope of VL graph. Okay. So slope of VL graph is also defined as potential gradient. More the slope, more is the potential gradient. Lesser is the slope, lesser is the potential gradient. So how we write potential gradient? Potential gradient, that is tangent theta, which is equal to slope of the graph, and is equal to K, which is equal to V by L. So potential gradient, mathematically we write tangent theta, which is perpendicular over base. Perpendicular side is potential difference or potential drop, and base side is length of the potentiometer wire. So slope will be equal to tangent theta. So then tangent theta we can write it as K. K is equal to V by L. So it is the potential gradient. Fifth, accuracy of potentiometer. Since K is equal to V by L, so more is the length L of potentiometer wire, lesser will be the potential gradient K. So more sensitive and accurate is the potentiometer. I repeat, more is the length L of the potentiometer wire, lesser will be the potential gradient K, more sensitive and accurate is the potentiometer. For example, graph of two potentiometer marked as 1 and 2 are as shown. Here potentiometer 2 is more sensitive and accurate, being in position of lesser slope. Okay. Assignment 3.7 continued. Question number 14. Graph of two potentiometers X and Y are as shown. Which of the two is more accurate and why? Question number 15. A resistance of R ohm draws a current from a potentiometer. The potentiometer has a total resistance of R0 ohm. A voltage V is supplied to the potentiometer. Derive an expression for the voltage across R when the sliding contact is in the middle of the potentiometer. So here is the answer. Now construction of potentiometer. It consists of a thin, long, straight wire AB of uniform area of cross section. Material used for potentiometer wire is an alloy like manganese or constantan, which possess low temperature coefficient of resistance. The wire is stretched over a wooden board along a calibrated scale for measuring length of the wire. In case wire is too long, it is arranged in the form of parallel wires. At the ends are connected by thick copper strips. These are thick copper strips by which their ends are connected to each other, so that the current flows through wires in series. A sliding contact called as jockey can be moved along the wire. A 1 meter wooden scale is fixed along the wire. Longer the wire, more accurate and sensitive is the potentiometer. Now measuring EMF of a cell. How will measure EMF of a cell using potentiometer? First, circuit diagram. AB is potentiometer wire through which a steady current is maintained by battery E auxiliary. C is primary cell whose EMF is to be measured. G is galvanometer for null point detection. Now, second point, procedure. Null point is obtained by sliding jockey J over the wire. When galvanometer shows zero deflection, then no current is drawn from the cell C. C becomes an open circuit and its terminal PD becomes equal to EMF E, which is equal to PD between AJ, that is, which is equal to V, and V is equal to K into L, where L is the length from end A and is the potential gradient of the potentiometer wire. Thus EMF of cell C is E, which is equal to K into L. Assignment 3.7 continued. Question number 16. How will you measure EMF of a primary cell using potentiometer? Explain with a proper circuit diagram. Thank you so much. Next time we will take up part 6 of this topic, which is comparison of EMFs of two primary cells. Till then, goodbye.